Okay, due to the working out required for this one, I've actually split it into two parts. I just can't fit it all on that teeny tiny piece of paper. So, first of all, we've got a building which is in an interesting shape. And we're given the floor plan, which is the cross section, because the floor plan is the same for every floor on this particular building. And then we're given the height. We need to work out the volume of the building. So first of all, we're going to find the area of the cross section. That's always got to be our first step. Well, what is the cross section? It's made up of two parts, as far as I can see. There is this part here. There is a square. And then there's this part here. Best way to describe that is 3/4 of a circle. So let's find the red bit and the green bit first. Square, easy peasy. (400 meters squared). And the circle, slightly more difficult. Think about the full circle. Well, that would be pi times the radius squared. The radius is 10, which is 100 pi. But we only want 3/4 of the circle, which is going to be 3/4 or 0.75 multiplied by 100 pi, giving me 75 pi. I haven't converted this to decimals because I'm going to put it into my calculator in a minute, so there's no need to. So the total area of the cross section is 400 plus 75 pi. I'm not going to put any units there for the moment, but hopefully you can see that this came from the square and this came from the circle. So now we've got the cross section. To find the volume, times the cross section, multiply the area of the cross section by the length, or in this case the height. So we've got this here, our 400 plus 75 pi. You'll notice I've put brackets around it. That's really important. I'll explain why in a moment. I'm going to multiply that by the height, which is 40. So, like I said, I'm just going to put this straight into my calculator. So I'm going to do brackets 400 add 75 pi. Don't forget to close your brackets. Multiply the answer by 40, and it gives you this answer. To 25,424, 25. Okay, that's for the nearest metre. If I did not have the brackets, you'll notice I get a completely different answer, a much smaller answer. That's because my calculator doesn't realise that I want to multiply all of that by 40, because all I've said is 400 add 75 times 40, and my calculator will follow the rules of operations. So it's really important that we put those brackets in. So that would be the first question. Now the second question is a similar type, but we've got even more bits. Luckily, this greenhouse is symmetrical, so we only have to find one section and then we just double it. Okay, so I'm going to divide it into a couple of different parts. I'm going to have my blue rectangle. Okay, and my blue rectangle is 2.4 multiplied by all of that, which would be 3.6. Giving me 8.64. Okay, so that's my blue bit. Now I'm going to have a look at my red triangle, which is here. What's that? Well, that's going to be base multiplied by the height divided by 2. Again, just straight into my calculator. 0.72. Hope I've got enough colours today. This triangle here, base multiplied by the height, divided by 2. Hopefully you've spotted what I've spotted. Actually, these two triangles, red and green, are exactly the same. It's just been reflected, so that's going to be 0.72 as well. And finally, I've got my little yellow rectangle down here, which is going to be 1.2 multiplied by 0.6. Again, giving me 0.72. Okay, what I do now is I add up all of these and I double. Why do I double? Because that's only half the greenhouse. We need the whole greenhouse. So 8.64 add 0.72 add 0.72 add 0.72 equals that to 10.8 multiply by 2, and we have the total area of the front of the greenhouse as 21.6. Obviously your numbers will be different. And then we need to know how long the greenhouse is, and it is 60 metres long. So to find the volume, it's the cross section area, and we multiply that by the length, giving me 345.6. Let's round that to the nearest metre cubed, 346.